Hello, electrostatic adinga lecture thumna na. Third lecture on electrostatics. Okay. Electrostatic potential to energy na potential energy bolde undin. So previous two videos achu first lecture achu Coulomb's law force bolo na. Abana chu electric field bolva to electric potential to energy na. Okay. So see, first we will do potential energy and then we will go into potential. Okay. Masa pena chu electrostatic potential energy yung kiti phala na. Betang potential energy for chu work power energy chapter ai bol tau chula. Potential energy idea pa chu na. Betang masa pena chu force hi conservative to non conservative chula na chila him. So if a force is a conservative force, then potential energy will be defined for conservative force. Okay. I have a force pa chu non conservative hong hi kha na example chu friction hovel na. Hong hi kha la chun chila chu potential energy umlaw chula na. So it is not defined, okay? So work power energy asong isayu taisa conservative force hoche pipita. Gravitational force na, spring force is actually electrostatic force na. These are 11-12 chapter syllabus aza hocho. Hichotum to main hizana. Chilala chu electrostatic force pa chu chilahi involved chu chilahi. Coulomb's law pa chu na. Evolve hitan eva potential energy for electrostatic force. Chu to hi evolve chu chilahi. Kasi banga chu electrostatic force chu conservative force hi je chu potential energy chu ki define so electrostatic force adinga chu na. So therefore we have electrostatic potential energy, okay? Batang idea potential energy idea hojong chu work power energy video never wala chun idea na naidu ta chu chu biham dele. So whatever if your work is done by conservative force, so that work done will be stored as potential energy, okay? Potential energy definition simple ta ase dinga chon chu potential energy kiti chu stored energy ti nei cho bale so work done by conservative force gets stored as potential energy, okay? So these things we have learned already. Potential energy is a stored energy and it is defined only for conservative force, okay? And in so electrostatic force, so that means Coulomb force is a conservative force, okay? So it means that the work done by conservative force, that means the electrostatic force on moving a charge from one point to another point depends only on the initial point and the final point. Hechi conservative force definition chulana. Work done by conservative force does not depend upon the path it chulana. It depends only on the initial and the final position, okay? So here it is independent of the path, okay? So hence electrostatic potential energy is defined, okay? About the important relation hi chojong hi work power energy ai bol sayo da cho che. Example, change in potential energy cho piham it is equals to the negative work done by conservative force. Okay, so U initial minus matang ati ta change in potential energy cho piha U final minus U initial cholana. So this is negative work done by conservative force. Okay, so from here you will have this one. U initial minus U final equals to work done by conservative force. Okay, apana cho change in potential energy is equals to external work done to relation to piham dele. So direct change in potential energy is equals to the work done by external force, okay? Right, melchi ta oche ten relation in manu so like chapter hai na. So first is change in potential energy is equals to negative work done by conservative force, and in so change in potential energy is equals to the positive work done by external force, okay? Aji ibola negative conservative force here ibola external force as a positive ham hi chawon chin value na aji chu alang pi akhu conservative ho hina it x opposite to external force, okay? Gravity ajong chi bol taw chalana. Example chu object mass kha chu kala ka shot if I lift an object, then gravity is downward, right? Gravitational force is downward but external force is upward, okay? So in the same thing spring ajong khovel chun, so if I pull the spring will pull back na. Spring force pa chu conservative force is a external force pa chu force apply pa chu chalana. So here in this case also, if you have a charge, if the charge is pushed by external force, so we will see that the conservative force electrostatic force is on the opposite side, okay? Two particle system derivation involved palem na, okay? Chu intro thempat na to hi potential energy hi two particle system apal ipat diu cho chala he. So chichu biham dele, suppose I have two charge, let's say Q1 and Q2 tiute. initially amani ka separation chu izar ham so let's say r1 tu te na khutile e honi p volume ham tele he q2 pa he lai omna pa hi in choi diu in so we have to bring this slowly okay till so here this position so now q2 will come here okay so when the position become between them becomes let's say r2 tu te na to chi volume chu bi ham tele q2 chu r1 distance apala chu in la diu r2 distance na ho in koi diu na okay so here we are going to bring the charge q2 very slowly okay NCERT textbook hovela jun award q kimang pa chu infinitesimally small ati cho jela hem all valentine velocity to negligible na because we don't want any kinetic energy to develop here okay to come into play here so we want the kinetic energy to be approximately 0 so we are going to bring the q2 very slowly na such that velocity is 0 tapang na td jing okay hotele tu hin q2 pa hin nan do so na so we are bringing this one hotele external force hilanga ki apply ha hilanga ki apply chola na so we are applying external force on this side hotele chalai charge then hi positive ila do so ani nya positive hi le chun electrostatic force of repulsion path opposite arm le cha okay right so we're bringing slowly let's say at an instant so let's say at an instant so the charge q2 was here okay so let's say at that instant the distance between q1 and q2 is let's say x tute okay na so at this point hichalai ang thun na hena ep volume ham tele so we're going to take a very small to e honi I mean ibola heci bolo ham na ibola chi bolo ham tele chun so hilai para charge q2 chu chalai para hilai nan choi wa chala na when you bring here so you have done some work okay so you have done some work and also so electrostatic work done force also to hilai force of repulsion pa jong hena so work done by conservative force jong di cho chalai him heci work done by conservative force pa chu potential energy of the system hong ki store de ta chu okay remember our main point is to find out the potential energy of two particles so place at a separation r2 okay chi head the dinga chu suppose initially hilaya omhun para hina so when they were separated in r1 ke separate hi energy to let's say 100 joule to na kutile q2 chu nan choiwa r2 anan koiwa hi energy so let's say now it is 200 joules kutile hechalai para chalai nan top sung wa chuna work done is an bolwa 100 ki habbe chula na chala hi okay 100 ki habbe che pa hi so this is the work done okay so whatever 100 to external force work done kyute kudele conservative force work done so minus 100 ki di cho na hi je pen hi potential energy ang ke store di cho okay right so here let's see so at a point at an instant when it is here let's say the charge on bringing the charge q2 by small distance x okay small distance dx tiuta na small distance dx hichalai para hi hichalai chan hi ka hin tol na hina so let's say the work done on bringing from here to here is let's say dw tiute so work done is dw so khutile to hi apa chung si hina to hin if I break down into small pieces like this ki bangsa chat na regular same interval khutile if I know the work done for one then I can add the work done for all of this okay chichu biha integration tina so basic integration meaning so na integration meaning so summation tina is so I will find the work done on bringing the charge from here to here and then I will integrate that small work done from here to here okay initial to final position okay then khutile at this instant okay mass charge pa ko value chun external force chilanga hi oma okay abana conservative force is a force of repulsion to chilangai am chalana si so here we can see that the external force is equals to minus x electrostatic force okay a direction chu ki banglo na opposite so a hi wanga magnitude pa chu f external force magnitude is equals to so fe heti approximately so a hi wanga chana heti pa hi slightly bigger okay than this that is why this q2 paso na hetilanga chilanga chi chula if the q2 paso chilanga chi le chun that means there is a resultant force on this side na chu pitinam tele he che pa he them khat lin cho tin cho che pa sanga he na suppose let's say this is 1000.1 newton newton khotele fe pa hi 1000 newton okay khotele khat pa he them cha khat a lin zo chula na ti ja cho movement zo all a chi tin cho Okay, but approximately they are equal. Okay, magnitude wise. Atile to ahi at this instant. So work done. Okay, on moving a small displacement dx. Okay, so dw. So this is equals to force, external force into dx. Okay, so work done is a force into displacement. So here p ball now we have to integrate this formula. Okay, work done. As it so dw hi pm tele chelai ka dinga work done box na to I honi hol no mo chu chelai para he chelai lung ke ya work done chi hol no mo chala. So therefore we have to integrate the whole thing. Okay, to hin ka integrate le chun. So dw chu work done, whatever work is done. Okay, so chipen hi work done by external force na work done by conservative force chu I can write here as minus f electrostatic force into dx. Okay, whatever work done will be stored as potential energy. Chisa so sila hi direct u initial to u final ka using so sila hi atila chu hila hi energy chu u initial hongi ting hila para hila nan tolwa chu na hila hi energy chu u final hongi ta chu. Okay, atile sila hi zat data. So let's write in the next page. Okay, integration of dw chu piha dx chu integration of dx chu x chu na x na. So therefore integration of dw will be w. Okay, abale ta to chu to hi work done hi hola ye holo ha chelai ta hi holo chola na when the separation was x. Okay, khutile chelai electrostatic force pa he pdi ha force of repulsion na coulomb's law pa chu. So k into q1 into q2 divided by x square. Okay, chichu ga replace leo chun. So work done from u initial to u final is equals to integral so minus k q1 q2 divided by x square into dx. Okay, chichu zat ha minus k q1 q2 hong podo dina constant integration of 1 by x square into dx. It's the integration ball pe leuchun is that the minus k into q1 q2 1 by x square so integration so is that the so 1 by x square so x power minus 2 tinai so it's in the integrate value power plus 1 ki ball zia abanle so divided by the power. Okay, so this is x power minus 1 divided by minus 1 chichu pitenaham minus 1 by x. Okay, khutile hechipa hi minus 1 by x and this is from where to where limit cho helaita atila chu r1 am chulana r1 apara chu r2 chani chidio. Okay, then we have to go from r1 to r2. So r1 to r2 khutile r1 to r2 to hin limit ga pu leuchun. So you will have u final minus u initial should be equals to minus k q1 q2 into minus 1 by r2 na koi masat diu minus plus 1 by r1. Okay, so now potential is that potase u final minus u initial should be equals to minus plus na k into q1 into q2 divided by r2 minus k into q1 q2 divided by r1. Okay, to chu chi hi ta chola na potential energy cho ale to hi reference khat in la cho gravitation in bolai ba cho na gravitation potential energy bolai ba cho ground level pa hi potential energy reference level ai la chola na. So we assume that potential energy at the ground level is 0. Okay, chito banga chu we have to assume that when the two charges are very far enough na, so tichu let's say when they are at infinity. Okay, when the q2 is at infinity gamlat base phalachun aman ki ka chu attraction repulsion force pa chun negligible hong ta chola na force chu omlo wala chun conservative force omlo wala chun work done jong omlo ta na chu potential energy jong omlo na. So therefore the potential energy becomes 0. Okay, when they are far enough. Chija chu hon assumption in volume pm tele. So we have to assume that when q2 was at infinity ama chu potential energy pa chu na 0 I assume diu chu chu pm tele if r2 is infinity. Okay, tichu r2 so gamtha na infinity hele chun we have to assume that potential energy initial was 0. Okay, tichu potential energy at infinity kidina chu. Okay, r2 infinity hele chun potential energy pa chu 0 hidina. So potential energy is 0 at infinity tinai chu ale chipen hinga put leo chon ping pot ding ham, so u final is equals to, so k q1 q2 divided by r2. Okay, or in general, so if like kan zita lo na zit no val zita bilang, so if two charges q1 and q2 are placed at a separation of r, okay, then the potential energy of the system will be given by, so in general, so two charge q1 q2 placed at separation r, potential energy to piding ham, so k into q1 q2 divided by r. Okay, it's a formula in ml zito two particle system ading potential energy pa na. So if I have q1 q2 placed at separation r, kutile amani ka potential energy pa na, amani system potential energy pa k q1 q2 by r. Okay. Okay, the potential energy of a charge q at a point is the work done by external force in bringing the charge q from infinity to a point. Okay, to ay ball pen so na derivation abon ay ball pen so infinity apara r2 apara in to vana r1 chan r1 r okay chila hi r1 cho in, so this is r1. Okay, initial separation pa so r1 cho na r1 to infinity hi chun u initial to 0 hi ngai na chila hi. Okay. Okay, so potential energy of a system of particles haokipiit jong le hi formula ina man kit dio work power energy equal work power gravitational equal to na gravitational potential energy. Examples equilateral triangle mass thomi ko ya find potential energy of the system ti hovel so na a bol dan ki pang chat chela hi repeat dio so la. Okay, abana chu potential energy of system of charged particles hi pen hi gravitation chapter na gravitation chapter potential energy equal pen chun na, so it is exactly the same thing. Okay, everything is repeat ki bang chara ka bol so potential energy chu you can also define like this, chu biham the energy or the work required, work done to construct the system. His system pa chu construct na dinga nan da tha sen do za chu na, or can say the work done, okay, or the energy required to construct the system, so that is the work done. Okay, ai wang chu chela tha sen ka ti wang chu chi external force lawin electrostatic conservative force bo ezom de na la him. So example, see, it is better if you see the example. Example chu particle nin panu to chela hi x and y na, particle ka chu chela ma charge, so let's say zala de ha, so 5 coulomb na example, so 5 coulomb is placed at 3,0 and you have another one, so let's say 2 coulomb, so 2 coulomb is placed at, let's say, minus 2,0. Question jo piham find the potential energy of the system. Okay, chu question cho khotile potential energy of system hola dinga chu hi system hi hon in tha construct do cho. Okay, we have to reconstruct the system. So on reconstructing the system, how much work you did, okay, how much work you do chipen chu total potential energy hongite na. Ale construct dinga so ma sapena chu 2 column hinan choiding of vintin chelain input dio na, abana hi 5 column painan choiding of vintin chelain input dio. Okay, so let's say u total chu piham ma sapena chu 2 coulomb khonan choiding of vintin chelainan koi minus 2,0 na koi vala chun, let's say the work done is or the energy is u1 na, work done will be converted into potential energy. Okay, bana kho 5 coulomb pa khonan choiwa 3,0 nan koi vala chun, let's say the energy is u2. Okay, the work done is u2. Ale to hi when you bring the 2 coulomb charge, okay, is a 2 coulomb painan choiwa hi a vel a hi ma cham no pichola na, so there was nothing. Okay, khutile is a 2 coulomb pa hi a repel thading a attract thading ima cham no cho. Only when you have attraction repulsion there will be a conservative force, electrostatic force omne cho. Ai wang je 2 coulomb panan choiwa hi electrostatic force ima cham no na, so therefore there is no potential energy. Okay, potential energy is not defined, so therefore use u1 is 0. Okay, abana u2 ko pi ha, u2 chu when you bring the 5 coulomb mass 2 coulomb pa hi ta chola na, it was already there. Okay, so this will provide force of repulsion, so therefore potential energy is defined. Khutile amani ka energy chu pham k q1 q2 by r na chala formula is pau hai. So that means k into q1 q2 divided by amani ka separation khojat ha zari them. So what is the total separation? So this is 2, this is 3, so you'll have 5. So 5. Okay, chin solve wala chu hising k chu 9 into 10 power 9. Okay, so into 2 into 5 divided by 5. So 5 cancel out. So 9 2 are 18 into 10 power 9 joules. Okay. Value hilit diu ta jana alang pia charge hong ki pe micro coulomb velang ki pi jana. Okay. Let's do triangle ka gawal ta na equilateral triangle. Okay, you are given equilateral triangle. A vertex zo se ahi charge so let's say charge q diutin chilai charge q ma charge 2 q diutin chilai charge 3 q diutin side to a diutu chilai so a question. So what is the potential energy of the system? Okay, then iti hold diuta kasi banga chu potential energy is the work done energy to reconstruct the system. Okay, so system pa hai na I reconstruct ki diu. So you have to bring first one mass and put it here, one mass and put it here, and then you have to put it here na thum ta amsala. So let's say it in 1 2 3 diu ta. Okay, ama sa pen pa ho ka hin ko ya chu na charge q pa ho ka hin ko ya chu chima sanga chu charge ema sam no chala na dang. So let's say here total energy will be given by u1. U1 so biham the work done to put charge q, okay, at this point, and plus u2 so biham the work done to put q 2q at this point. Okay, abana so plus u3 so biham the work done to put 3q at this point. Okay, atile to hi u1 an choi wa hi kasi banga chu masanga charge ma cham lo na, so therefore potential energy chu 0. Abana u2 nan choi wa hi charge q pa ta chal na, it was already there. So let's say here u on 2 due to 1 amani ki ka hi attraction repulsion that's a force of repulsion na, so therefore you will have potential energy between these two. Let's say that is u21 abana so 3 dan so hi, so when you bring 3, 1 was already here and 2 was already here. Okay, let's say u on 3 due to 1 plus u on 3 due to 2 0 plus between 2 and 1 potential energy formula so apply lachun k q1 q2 by r pen na, so k into q into 2q divided by separation who a na, plus between 3 and 1 k into q into 3q divided by a. Okay, plus abana between 2 and 3 chito hinchi na 2 and 3 so so k into 3q into 2q divided by a. Okay, just add all of this. Kq squared divided by a to common na. Masapin ako 2 plus 3 plus 3 2 are 6. So total energy is at 6 7 8 9 10 11. 11 kq squared divided by a. Na chi PM tele, this is the energy required to construct this whole system. Ay lole potential energy of this system. Okay. Question khat to solve biya na. 4 charges are arranged at the corners of a square of side D. Find the work done to put this together. Okay, arrangement. See NCRT question cho sila him. Tang step su te he taw sula na bolan so charge khanan choi diu nan koi masat diu abana second charge nan choi diu nan koi diu abana third charge nan koi diu na abana fourth charge nan koi diu. Okay, then let's see here. Let's say charge 1 2 3 4 diu ta na. Total energy to piham, I will bring the first mass, first charge, and then I will bring the second charge, I will bring the third charge, and I will bring the fourth charge. Na u1 to piham first charge na hin lava and work done pa na, u2 to piham second charge na lava work done pa hiza, bana same thing for 3 and 4. Kutele u1 kan choya chu amasanga charge dang macham lo na, so energy is 0. u2 kan choya chu amasanga chu 1 ta chula na, so between 1 and 2 you will have potential energy u on 2 due to 1. 3 kan choya chu amasanga chu 1 to 2 ta chula na, so therefore u on 3 due to 1 plus u on 3 due to 2. So plus 4 kan choya chu 1 2 3 upon vam ta chu. Okay, so therefore you have between 1 and 4, between 4 and 2, and then between 4 and 3. Okay, just put the formula k q1 q2 by r. 0 plus between 2 and 1. 2 to 1 ho cha, chi 1 chi 2 chula na. Amani ka energy cho piham k into 1 who minus q, 2 who plus q divided by separation to d. Okay, plus between 3 and 1. 3 and 1 cho ho cha, So G1 is a G3 chula na. So if you have a square, diagonal chu is at the diagonal distance chu. Side ko D hile chun diagonal chu root 2 into D na. Okay, you have K into 3 chu minus Q abana between 3 and 1 1 ko minus Q na. So divided by separation chu root 2 into D. Okay. Plus abana so between 3 and 2. So K into 3 chu minus Q is a 2 chu plus Q divided by separation chu D. Okay. Plus between 4 and 1. 4 to 1 who 4 chu plus Q is a 1 chu minus Q na separation chu D. So K into 4 chu Q is a 1 chu minus Q divided by separation chu D. Okay. Plus well I get that. So now 2 1 3 1 3 2 4 1 to 4 to 2 na. So 4 to 2 is that plus K into 4 to Q 2 to Q divided by separation to root 2 into D. Diagonal mama chala na 2 to 4 ke ka ako. So finally between 4 and 3 K into 4 to Q 3 to minus Q divided by separation to D. Okay. It's also in here advising na so. Okay, you try to add them. What will you have? So minus KQ squared by D khat na. Minus KQ squared by D ni na. So minus KQ squared by D thum minus KQ squared by D li. Okay. So that means you'll have 4 times minus KQ squared divided by D. Okay. Abana khat khola le khat te ni ko. So chila hi minus minus to plus na. So you'll have KQ squared by root 2 into D. And then you'll have a KQ squared by root 2 into D. Nita na. So I will have 2 into KQ squared divided by root 2 into D. Okay, this is answer here na. Let's solve bedum vazon le root 2 to 2 ke cancel achun root 2 remaining. Chilai chu data. So minus 4 plus root 2. Okay. So KQ squared divided by D. So here potential energy of the system. Okay. To chu system khan haokipiit ala chun system potential energy hol dang pa chuna. Chu easy lo tan ten to hi he next step pa chuna. Next step pa chu pi ham tele azolanga relation kan si pa chu change in potential energy is equals to positive work done by external force di pa chuna. So U final minus U initial is equals to work done by conservative external force na. It's a pie so as you system new na. For example, you are given one system system hung about system pa tempat hung change home na change home then you will have another system and they will ask you how much work is done to convert the original system to the new system. Okay, right? Here's a formula na man diyo okay. First let's do some example na. Suppose people do let's take a 2 mass na. Suppose you're given 2 mass x and y axis ahi. So mass khat chu original mass hello charge e bolo so to he charge khat chu original na. Let's say there is a 5 microcoulomb charge. Okay, alo value put out tempat q tu na charge q chu original maintain abana charge dang khat pen chu let's say it is at say this one is let's say 2q tu 2q pa chu zaram di ha. So let's say this is at a, 0 tu na. Okay, so now it's a initial situation so initial situation chu q pa chu khat chu 0, 0 ama 2q pa chu 0 am na. To chu pin bol di hom te he 2q pa he in tolding of then. So we're going to put this 2q at let's say at a 2a, 0 in koi diu na chila he. Okay, so 2q pa he chilai para he 2a, 0 he in koi diu na. Kutile he china bol sung he china bol sung was work done in the bol dova. So how much work was done in moving to q from a, 0 to 2a, 0? Okay, that is the question. Hite ai hong ki dongji na work done hovel hong ki dongji so the way to do is masa pena chu akitol masanga chu system chula na. He system pa potential energy chu hol wala chun u initial da cho. Okay, to hong ki tol zawa chu he system here thata cholana japan here. If you find the potential energy of the new system, you will have U final. Here value pass minus bolachon. U final minus U initial, you'll get the work done. How much work you did to move the charge. Okay. Okay, then khutile U initial chu zadingham. Aki move masanga chu 2q chu a, 0 ama q chu 0, 0 amna. So k into q into 2q. So divided by separation between them is a. Okay, chu 2kq square divided by a. Kutile nan move zawa chu u final na. Nan move zawa chu k into q ki bang na lai na. Aki khi chu pihan distance ki khita chu. To hi za ta separation here. 2a ta chu la na. So now you have 2a separation. So divided by 2a. Okay, that diha chi. So here you have kq square divided by a. 2 to 2 cancel out na. So khutile work done that ha. So work done by external force will be equals to, so u final minus u initial. U final to that ham kq square divided by a minus u initial to u initial to 2 into kq square divided by a. Okay, that has been minus bolachon minus kq square divided by a. Okay. Chita banga chuna system question hong kipi jana. So let's do one more. Okay, chila his square kipi. Tempat idea concepts in here tending was na. Okay, let's take one question. Suppose let's say equilateral triangle kipi tu na. Ita kipi intin. Ale the triangle ahi pm tele charge ita ham jana. Charge q to charge q ita ham na. Side to a tu equilateral triangle same side. Ale to hi ptm tele he charge q pa hai na. So let's say a b c. Okay, and say d p q r tu te. Okay. Kutile charge a pa he hong ki tolding then you will bring this charge a and put it at q. Okay. Bring this charge q at b and put it at q, and then bring charge from c and put it at r. After you bring, so the whole thing will be like this. A, B, C. Tochu bina hu charge q pa som da na a pa nan choi wala chun. Abana bina charge pa chu nan tolwa q na he koi diu na chila he charge q ding tin. Abana c a q pa chu na tolding tin. Chila he to he r ta cho chila he. So now you have p, q and r. Kutila he chenan bol na sung wa he work done is on the ball do na. So how much work was done on moving going from, let's say system 1 to na system 1 to system 2. System 1 apala system 2 chan change the thing ahi work done is ki bol so that is the question. Okay, so everything is same na. Masapena so u initial na loading of intin, u final na loading of intin, cheten subtract na ball vale work done by external work done pod na. So first let's find out u initial. U initial to 18 loading of ham potential energy bolan ka hilta so na you have to reconstruct the system. Okay, first you will bring the first charge at a, you will bring the second charge at b, and then you bring the third charge at c. Kutile u a tiute na a na pa hokan choya chu work done was ua. When I bring the second charge was ub, when I bring the third charge was uc, let's say. So like we say ua to 0 heading ub pa nan choiba chu you will have a force of interaction between a and b na. So you have u on b due to a, okay, plus c pa nan choiba chu you will have u on c due to a plus u on c due to b. Is that the 0 plus b to a who k into q to q square, k into q to q square divided by separation to a na. Between c and a k into q to q square divided by a hiket na. Plus between c and b k into q square divided by a kibang na. Kutile initial energy to pm 3 times kq square divided by a. That's to u initial. Okay, then to final pa ko na. Final to pitam, final to system evaluation, you will have another equilateral triangle. Okay. To total side he q biha a chola na. So that means half of them will be a by 2. So that means you will have a small equilateral triangle side a by 2. Okay. Ale chipa energy ko hold kero na ki bang cho. So u ilahi final ta na u final chu you will bring the charge at p up abana Q apa honan choiding within abana R apa honan dop diu na koi diu. So when you bring the first charge, potential energy was 0. To chu chilai pen ke ball pen hina hilai apa hilai nan transfer power chumbele cho. To potential energy holding wal zon chipa hi. Let's say you have a system like this. You have to reconstruct this system, okay? Not from here to here. Chipen chu low. I want you have to construct this system. That is how you find out potential energy na. Kutele U P to 0 plus Q nan choiba cho between Q and P you will have interaction. P was already there na. Abana R nan choiba cho between R and Q you will have, and then between R and P. Okay. Is that the term 0 plus between Q to P ki ka ho K into Q to Q square by U P Q to that ha A by 2 na. Plus R to Q ho K into Q square divided by A by 2 kibang na. Abana R to P jong hu K Q square divided by A by 2. Kutila thum tam ta na to he. So therefore 2 goes up 3 times, that means you will have 6 Q square divided by A. Okay. Atila to hi final potential energy ta initial ta na. Kutile system wana pala system 2 chana china wa work done is that ham. So that is given by, so work done is given by U final minus U initial. Okay. Is that ang podo di ham 6Q square divided by A minus 3Q square divided by A. Chichu 3Q square divided by A. Okay, so this is the work done by external force. Okay, a concept pa so clear tao boltan pa so na. Initial energy pan hold on masat diu, final energy pan hold on diu, apan then you subtract na bol diu na chepala chun work done by external force ang podeta jo. Okay. Okay, then let's try to solve some actual questions na. HI JEE question boi bol diu na. HI CBSE board exam bazang kitong cho. So it is very likely that they will asking any exam na, entrance exam. Okay, question here value chun in the first configuration 1 HLI pen hina. 4 identical charge kibangso ke charge or Q not abona are placed at the corners A, B, C, D. So square side to length side to A na chala A okay. So in the second configuration 2, the same charges are shifted at it. So I so now they are shifted, okay, to midpoints Z, E, H, and F. Okay, as also equilateral triangle bolza to a square that so. If K equals to 1 by 4 pi epsilon naught, the difference between potential energies to a direct work done at within difference at na. Difference in potential energy between configuration 2 and configuration 1. Okay. Na bolde hojing na chala U initial chiza U final chiza minus bolde sun chu difference jing na. Space on base here so option hok koi lo ta so chala hi. So but you know how to do it, right? Okay, then let's do it. Masapena so U1 diu na configuration 1 apa here. Is that dingham? So you have how many charge? Let's say 1, 2, 3, and 4. Okay. So when you bring the first charge, it is 0. To step can skip it. So I'm going to skip some steps here. So 1 nan so iba energy 0. 2 nan so iba so 1 was already there. So between 1 and 2 you have K into Q to Q square divided by A. Okay. Abana chu 3 pa honan so iba chu 1 to 2 was already there na. So between 3 and 1 K into Q square divided by root 2 into A. Aso kasi iba so diagonal chu 1 chu chi is a 3 chu chi is a distance to root 2 into sides. So A. Okay. Abana so between 3 and 2 K into Q square divided by A. Okay. That's 3 ki chaita 4 nan choi diu na. So 4 nan choi was 1, 2, 3 was already there. Okay. So between 4 and 1 KQ square divided by A. So between 4 and 2, KQ square divided by root 2 into A. As you 2 to 4 who diagonal na. So and finally between 4 and 3, KQ square divided by A. This is solve lesson ang pot ha. So KQ square by A to lita na. So 4 KQ square divided by A. Abana KQ square by root 2 A to nita na. So 2 into KQ square divided by root 2 into A. So root 2 gets cancelled out. You have root 2 remaining. So initial energy to 4 plus root 2 into KQ square divided by A. Okay, equation 1 tibte. See configuration adding configuration 1 pa potential energy na. So second na pa jong kono hol ke diu So second napa ko value chun. So now you have another square, smaller square. Okay. Is that their sides here? And that is only the tricky part. Okay. A side who is that them. So you know that this is a by 2. Okay, this is a by 2. Ale khat pa hi that x ti leo hen right angle triangle am chala na la hi right angle triangle. Pythagoras theorem man le chun. So this square plus this square will give you the value of x. X to pm. So a by 2 the whole square. Okay, plus a by 2 the whole square under root. To choose that ham a square by 4 plus a square by 4 under root. To 2a square by 4. Okay, 2 1 is 2, 2 2 are 4. Chakuna so a by root 2 hung po just like. Okay. Right, so you have a square, so a by root 2. A by root 2 is the side. Okay. Chiki huro diagonal zone hold on like. So here what will be the diagonal? So root 2 into sides. So that means here diagonal is root 2 into side to become a by root 2. So that means the diagonal is length a. Okay. Okay, now you find out the final potential energy U2. U2 to become ama sa pena chu to hi 1 2 3 is that a na pa chu hoila ketia. So shifted a na pa chu zia ke shift na kutele chila chi pa hi chila ke shift ne chu. Okay. D na pa hu ia ke shift ding tin C na pa hi H ke shift ding tin B na pa hi F ke shift na. So therefore you'll have 1 2 3 and 4. Got hazi udina diagram chu confused on again. So I have a small square. Okay. I'll try to rotate this. So something like this. Na di chat hi zong le. Chilanga hi charge Q. Q not a Q ka ga za if you want you can use Q not. So charge Q so ke ya. A side to piham a by root 2. Okay. Side to a by root 2. Diagonal to a na. So now you have 1 2 3 zong ka put it. 1 2 3 and 4. U2 to piham. First I will bring the first charge. I will bring the second charge, I will bring the third charge, and I will bring the fourth charge. Na 1 na pa ka hinsoya chu work done 0. Okay. 2 na pa ka hinsoya hu 1 pa chu da chola na. Between 1 and 2 chu piham k into q square divided by a by root 2. Okay. Abana chu 3 na pa ka hinsoya chu 1 to 2 da chola na. So between 3 and 1 k into q square divided by a chola na diagonal chu. 1 to 3 ko diagonal ama plus between 3 and 2 kq square divided by a by root 2. Okay. Abana chu 4 na pa ko nan chai diu 4 na pa nan chai wa chu 1 2 3 ta na. So between 4 and 1 kq square divided by a by root 2. Okay, plus between 4 and 2 kq square divided by a. Azi chu 4 to 2 ko diagonal am chala na. So plus between 4 and 3 kq square divided by a by root 2. Here's solve lesson ham. So k by a by root 2 tampa ko lita omna. So 4 into kq square divided by a by root 2 hung ka urito chunga. So here you'll have 4 root 2. Okay. Plus 2 times of kq square divided by a. Chihina. Is that ang podo di ham chila hi. So you'll have here 4 root 2 plus 2. Okay. kq square divided by a. To hi final u2 zong ta na question chen pido ham u2 minus u1. So the difference at ichula na. Khotele u2 minus u1 chu za ding ham. So 4 root 2 plus 2 kq square divided by a minus u1 chu 4 plus root 2. 4 plus root 2 kq square divided by a. Chibe subtract bolao chun na. Kq square by a chu common hiza. So remaining chu piham 4 root 2 plus 2 minus 4 minus root 2. Chichu, is that only there? So 3 root 2 minus 2 kq square divided by a. Okay, so this is the answer. Okay, abana same question na. bolar ki bang so chelai jong hi velo chun. So two charges Q1 and Q2 are separated by distance 30. System ki pipa na figure ahi. A third charge Q3 initially at C, so C oma, is a move along the circular path, okay, to point D. So radius to 40 centimeter radius na. So if the difference between potential energy due to movement from C to D na, so D ahong ma final is C ahong ma initial na, a difference pa G ki pi chila hi hotela K value hui za idem. That is the question, okay? Same question na. Let's say so you a balance ki bang so initial potential energy to whole vilang, final potential energy to whole vilang na. Just subtract bola to choosing so initial to the bang ha Q1 to chila ma, okay, Q2 to chila ma na, to Q2 is a separation to ham 30 centimeter, okay, Q3 to yamam Q3 to chila na chila so to Q3 is a separation to 40 centimeter, okay. Hotila Q2 to Q3 ki ka distance is them. So tang triangle ka say so bol lang pa pia. If you have a triangle, you have 3, 4, and 5. So angle is 37, 53 ti ho na. So actual questions are asked here, okay. 50 centimeter hi dina la hi. Okay, you will have 50 centimeter. Okay, Pythagorean triplet ki 3, 4, 5 po na. Right angle triangle patia ki feet G initial system za final system chu pi ha to chu Q3 pa he ta hunga hilai hung chu ala chun final system chu na so Q1 chu chelai hum za chu Q1 Q2 chu ki khelo na Q1 to Q2 chu at a distance of 30 centimeter abana Q3 pa chu hilai hum da chu so this is Q3 radius to 40 centimeter na so 40 centimeter chi hi za chelai hi 10 centimeter hi ngai okay. Okay, then let's find out U initial, U final, and subtract them. U initial to piham. Kasi banga chu, let's say 1, 2, 3, Q1, Q2, Q3. 1 ko na put diw within, abana 2 na put diw within, abana 3 na put diw na. So U initial. 1 na put va chu 0 na, initial energy. So 2 na put va chu 1 was already there. So between 1 and 2, K Q1, Q2 divided by 30. Okay. So plus, when you put 3 na hinko va chu 1 to 2 was already there, okay. Chija chu K into Q1 between 1 and 3, Q3 divided by 40. So between 2 and 3, K into Q2 into Q3 divided by 50. Who low in tin koi tawa so phala subtract in bolyo jana tam ki cancel hongum ni chu aji chu Q3 bo se ki hel cho position chu. So now let's find out U final. U final so piham Q1 hunan put va chu energy to 0 na. To abana Q2 nan put va chu ipiha 1 was already there, so between 1 and 2 Q1 Q2 by 30, okay, plus 3 na input va chu 1 to 2 was already there, okay, so between 1 and 3 Q1 Q3 divided by 40, and between 2 and 3 Q2 Q3 divided by 10, okay. So now let's subtract them. U final minus U initial is that the a value here so Q1 Q2 divided by 30 plus Q1 Q3 divided by 40 plus Q2 Q3 divided by 10. G final na minus initial value so ban ji lechun. So Q1 Q3 by 30 abalan so piham between 1 and 3 Q1 Q3 divided by 40 minus between 1 and 2 and 3. So Q2 Q3 divided by 50. So this cancel out. Okay, so 1 3 gets cancel out. Remaining to piham. So K into Q2 to Q3 common na. So 1 by 10 minus 1 by 50. Okay. Got solve lessons on pot there. So Q2 Q3. So 50 minus 1 to 40 divided by 50. 10 to 50 to LCM to 50 is in there. So okay, here you'll have 4 now. 4. Okay. Okay, abana chu nehe di hoju chelai centimeter i bol so meter ki convert na lo so now you have to convert into meter. I lo abuya la chun chala converging daw chala hi. So here 10 centimeter means, so okay, next. So k q2 q3, so 10 centimeter to 1 by 0.1 teenager in terms of meter na. So minus 1 by 0.5. Okay, so how much will you have? Okay, you take LCM. LCM is that k into q2 into q3. So divided by 0.1 into 5 to 0.1 na. So 5 minus 1 divided by 0.5. LCM to 0.5. So k into q2 into q3, 4 by 0.5 to 40 by 5 teenager. Okay, so that means 5, 8 are 40. So 8 into q2 into q3 divided by, so k to 4 pi epsilon naught. Okay, so it's difference na. Question na pi do tam, so q3 into k pi na. So q3 into k to pi ha. So k to 8 q2. So this is k. Okay, 8 into q2. Okay, abana hi potential na. To chu potential energy hi polo ta cho. System two particle system potential energy chuna k q1 q2 by r jo formula hai. System khan hong ki piale potential energy holta ne ding within system ma jo changes hong ki bola la chuna. So work done chu zading ham final minus initial concept pa chuna chipen chuna apply dio. Okay, now let's see potential. The potential at any point is equals to the electrostatic potential energy per unit charge. 18 mil si jing taw aji chu ta explanation jong ha bolan ka ting na chila theory jong ha lu base loading e hon here chu pi ham electric field chu pi ta. So force divided by charge it chu na chito banga chu potential jong chu pi ham, so energy divided by charge. Okay, so the force per unit charge to electric field hi banga chu energy per unit charge pen chu na chu potential kiti cho. So you just remember it like that na. So potential is defined, otherwise definition zat kipia na buka NCERT yazong kipia. So potential is defined as the work done in bringing a unit positive charge from infinity to a point. With the energy chu piha, the work done in bringing a charge from infinity to a point na zo lang derivation in bolo chu. Hichi energy per unit test charge pa na chu potential kiti cho. Chija chu potential chija chu definition jong na ki bang thim ve ta. So simple thing, simplest way is remember potential energy per unit charge to potential tine cho. SI unit of potential to volt na. Okay, chu bale ta chilai par hi ham tele. So energy pa chu pi ta. Suppose hi chilai charge kharam cho na plus q source charge. Ale test charge kha chu infinity akuna na hin choi wala chun. So when you bring this charge small q from infinity to this point r, the energy is k into q divided by r. Okay, so this energy per unit test charge chu potential na u by q. So that means k into q divided by q into r. Q cancel chun v chu ping podam kq divided by r. It's a formula for potential. Okay, electric field jong chu charge khar bo se akuna electric field ke hol thai chola na chita panga chu potential jong chu charge khar bo se akuna potential ke hol thai cho. Ai wanga force holding a chu charge ni ngai chola na q1 q2 abana energy holding a chu charge ni ngai cha na. So like that relationship pa na ki bang thim ve cho field to force ki relate ta panga chu potential to energy jong ki relate ket na. Okay, chi formula pen hi mel si deu chu na kq by r chu potential. Okay, abale one very important thing na chu pm tele hlai charge pa na, so you have to put along with sign. Okay, azo lang chu ka sei lo wanga chu question ko bola chu sign jong ko put chula na mel chi le chun mutang hilai hi formula chu pi ta derivation jo chu chi pen hi chula na. So here put q1 and q2 along with sign. Okay, sign to no koi tha deu na ji chu question in solve na wa jong ka apply beta hoi lai ta chilai jong hi video chun minus q om na lai so minus q ka put chula na formula minus. Okay, so k q1 q2 by r chu q1 to q2 jo along with sign na put deu na chita bang jong potential a jong chu along with sign na put deu cho. Okay, so here right, you have only one formula, so put along with sign energy ta bang cho na. Okay, let's solve question. The value of electric potential at a distance of r 9 cm from the point to hi charge ka ki goi cho jala point charge khan na chu q is equals to 4 into 10 power minus 7 coulomb na kutele at a distance of is at 9 centimeter away at the point, what is the potential here? Formula to k into q divided by r. Now formula to direct input lesson. K to 9 into 10 power 9. Charge to be 4 into 10 power minus 7 divided by distance to 9 into 10 power minus 2. Convert into meter. Here's the solve lesson. So 9 cancel out. Okay. So minus 7. So here you'll have plus 2. Minus 2 ko calculation plus, you'll have plus 4. So 4 into 10 power 4. Okay. So option D. Simple question. Oh, direct formula application. That's here. Okay. Next, you have two charges plus 10 and minus 20 are placed at a separation of 2 centimeter. Charge neum. So plus 10 microcoulomb to hatsu plus 20 microcoulomb. Na separation to 2 centimeter. Okay. Find the potential due to the pair of the at the middle point of the line joining. So at this point you have to find out the potential. 10 microcoulomb pa hi p pa hoi chana gamla am 1 centimeter na abana 20 pa khu p pa chana gamla am 1 centimeter. Okay, we have to find out potential. Potential to a scalar vector ho setting also energy to potential ani nia scalar so direction is not important, simply addition na also energy equal also velocity upon so direct addition equal to jing na without any direction. Chito bounce of potential as in direction ngai lo, just add everything. So v total will be v due to 10, so v1 due to 10 plus v due to 20. Okay, v due to 10 so that hum kq by r. K to 9 into 10 power 9, Q to piham 10 into 10 power minus 6 micron divided by 1 centimeter away, so 10 power minus 2 plus due to 2 KQ by R, K to 9 into 10 power 9 into Q to zadham 20 into 10 power minus 6 micron bana choose distance to 1 centimeter. Okay, depending got solve na. So minus 2 you'll have minus 4. So minus 4 you'll have plus 5. Again, kibang na sila dong hi plus 5 om de. So 9 into 10 so 90 into 10 power 5 plus 9 to 18 180 into 10 power 5. Is that income? So 270 into 10 power 5 volt. Okay, you need pass na voltage sila. Or you can say 2.7 into 10 power. Is that the sila ko 7 volt. Okay. Question niyo sa na. So direct application ho. So you have one more question here. Two particles A and B having charges of kpm, so plus 2 into 10 power minus 6 microcoulomb din so to minus 4 into 10 power minus 6 coulomb. Separation to 20 centimeter na. Question 2, locate the point along the line AB where electric potential is 0. Tang chipen hi force apala sin bolta so find the point where the third charge should be placed such that the net force is 0 ati na. Abana feel to find the point where the net electric field is 0 ati ba to potential azon ki bang so find the point where the potential is 0. Hichai ab ammo thoma he na a technique pa ki bang technique pa phem the charge the given charge then sign ki ba na nature ki ba la chun. So the charge should be in between them. Alai ta som na mane ki ka chu ai wanga charge then nature ki ba lo khat positive ya khat negative hi la chun hoilangam de ha anio pa kop langa zo na on the side of the smaller charge de chu na khutila chalai jong hi potential 0 cho hoilayam ham, so it will be on this side. Minus 4 sanga plus 2 junior so na magnitude acho magnitude y sa cho khutile let's say this distance is x tiute. Okay, khutile chipa he za ding ham chipa hi 20 plus x. Okay, so we have to find out potential at P. Is that income? So due to plus 2 who k into charge 2 into 10 power minus 6 kq by r na x. So plus minus k into minus 4 into 10 power minus 6 divided by 20 plus x. So this should be equals to 0. Potential 0 kiti chula na. Kasi mga charge to along with the sign na ko yung ngayon. Kutile zata chila k into 2 into 10 power minus 6 by x should be equals to k into 4 into 10 power minus 6 by 20 plus x. Okay. Minus 4 should transfer wala chun plus 4 ki suta na. Cancel cancel chun. So this cancel out. So minus 6 cancel out. 2 1 is 2. 2 2 are 4. Okay, that means you will have is that talahe. So 20 plus x should be equals to 2x. Or you can say x is equals to 20 centimeter. Okay, chalahe na. Okay, to one more thing here. Potential kasi mas potential to direction mo pala na. Chizia to it's a technique by apply wang wahi. So there is also another point here, okay, where the potential is 0. Let's try to find that one. Suppose to 2 into 10 power minus 6 na chalahi kumcho. So khatpa chu minus 4 into 10 power minus 6 coulomb. Okay, so let's find out the point in between them where the potential is 0. Q tiuta chalahi. Okay, so let's say chalai para chalahi x cholana. So then this will be 20 minus x. Okay, as you separation between them to 20 he cha cholana. Kutila jo bang chona bol thai chalahi. So k into 2 into 10 power minus 6 divided by x should be equals to I direct ka transfer da so sila k into 4 into 10 power minus 6 divided by 20 minus x. Okay, is that the haji ka solve leo chun k to k cancel out. So minus 6 cancel out. So here 2 1 is 2, 2 2 are 4. Kutila 20 minus x should be equals to 2x. Okay, kutila 20 to biham, so 3x. So therefore x is equals to 20 by 3 centimeter. Okay, and here dekho chu chalai potential hong ki to phala na point khat bo sia he potential 0 here also. So there can be more than one point where the potential is 0, right? So you can find out those things. Okay, to chu chalai example kha kan bol jana chilong hi chalai jong hi potential 0 he ja chalai jong hi potential 0. Okay, so point here also potential is 0, so here also potential is 0 na. Okay, then hechen chu chikoi sora hinten abana last topic for this lecture na. It's a relation between electric field and potential. Question jong kitong nom thau na chalai hi. Ikhad batang potential energy relation is same as ni ka sai chala na chalai hi. Khat chu u initial minus u final should be equals to work done by conservative force. Khatpen chu u final minus u initial equals to work done by external chipen chu is outside ta cha. To chu chipen hi in man ki diu chu. So here as I say bang wa chu v chu piha u by q chula na. So therefore u is what q into v. Okay, abana for field chu piham field chu force by q. This is a force jong chu q into e. Tun ga substitute la chu nine u initial minus u final chu work done chu piha integral f into dr. Na chu chula work done chu. So here u initial to piham q into v initial minus q into v final should be equals to integral q into e into dr. Tam do se q na q cancel out divide by q every time. Kutile v initial minus v final equals to integral e into dr. Okay, now you have a new relation between electric field and potential difference. Okay, so we are going to use this formula and solve few questions from here. You can also rewrite like this. Dr ki pa he dr pa he dx jong thai dy jong thai dz jong thai so detail di one is inum wala na. So v initial minus v final so piding ham integral e. Okay, so dx I cap dot e dot dr. So plus dy z cap plus dz k cap. Now here a more detailed formula. Okay. Question na chu E chu na electric field a chu x to y tam I cap to z cap ahong mala chun chite ni man chan la de na I cap z cap k cap tam ahong mala chun so dz chan la de. But if it is given only I cap khutla dx pose na de na only z cap kp ala chun dy pon la de. Okay, so like that. Okay, direct question solving na example ma bol lawin. It's a formula ni hello ke sizing so jelai choosing. So here first question to 12 joule so energy chukupi na of work has to be done against an existing electric field to take a charge q from A to B. How much is the potential difference? More formula apply thina ka question here. So V to pm U by Q. U to kpm 12 joule, Q to kpm 0.01. So 1200 volt. Okay, potential difference na. Okay, next problem. So electric field 20 field kipi na sila here. So this is E. Okay. Exists along the x-axis kotiya sun E to pm E to 20 I cap. Okay, Newton per coulomb. Azo chalai formula ka sai chula. Hila electric field pa hi E dot dr. So Japan E dot dr na vector jani ni here. So E dot dr. Ale PKPM calculate the potential difference. So B minus VA. So where the point A and B are given. A choose a KPM. So now A part hovelauchun. So point A to 0, 0 na. So 0, 0 apara hi na cheating of intin. So towards B. So B is your final point. Chichu 4, 2. Okay. Kutila chalai ka A to B ka potential difference is adding ham. A formula chapyam V initial minus V final equals to integral E dot dr chola na apply lauchun. So V initial to A has a VB should be equals to integral. So 20 I cap. Okay. So dx I cap. dy z cap kasi lau ta so I cross z I dot na I dot z here to 0 also. So only I dot I have to do it. VA to VA minus VB to zarang podam. So here you'll have integral 20 into dx. Okay. Limit to here para hilai ham x value hi value x value to 0 para 4 chan chula na. So here limit to 0 to 4. Okay. Integration ga bolachun. So 20 to constant hung pododing integral dx from 0 to 4. Integration of dx to x is a. So you will have 20 into x is from 0 to 4. So 4 pulachun 80 volt. Okay. I have a question P do VB minus VA do chola na. So VB minus VA to zading ham. So minus 80 volt. Okay. Chichu answer na. Nabana B part jong ko velojun a bolan ki bang chat. Okay. So let's do B part. B part jo hela pa hela chan ham A to 4,2 apara B to 6,5. Okay, 6,5. So therefore VA minus VB ki banga Japan integral 20 I cap. Okay. So dx I cap. Atile is that have VA minus VB to so 20 okay integral dx ki bangna a limit ba ki khelba so chela hi x hi 4 apara 6 chanchi so chela hi so you'll go from 4 to 6. So that means 20 into integration of dx to x is ana chela hi limit to from 4 to 6. Value pollution 20 into 6 minus 4. So that means 20 into 2 is 40. Okay. Kutile VB minus VA to zadingham. So VB minus VA will be minus 40 volt. Okay. Formula mandan chuna he thene ngai ga bol zana chala him. So here no bela chala jong hina. So dy z cap plus dz k cap na ji thei no problem. I was a dot on ki bola chun like terms of ki multiply ji chula na chala hi. So this will be gone. Okay. Okay, next problem. Electric field ki pina chala hi. Electric field choose ke pm. So 2 I cap, 20 I cap, plus 30 z cap. Okay, Newton per coulomb. If the potential at origin, so origin ki so point A ka na origin to 0, 0. Point A is taken to be 0, then find the potential at B to pm 2,2 given chu piham so va chu 0 ke pi chu hala hi kutel azwana bol tabang masam bol ke lechun v initial so va minus vb zadingham integral so 20i plus 30j to chu I cap to j cap om chula na to hi so therefore you can take a dx I cap plus dy j cap k cap la ngai lo na je ju dz la ngai lo je ju k cap no ja chu so here you'll have what va minus vb chu sarang pododing ham so integral so 20 dx okay plus integral 30 dy x limit chu hoya pa holai chan ham so from 0 to 2 y limit jongkhu from 0 to 2 ga bola sun chi pahina toiding pododing integration of dx to x hongding from 0 to 2 plus 30 hong pododing integration of dy to y from 0 to 2 so that means if you put 2 you'll have 40 plus if you put 2 you'll have 60 to 100 okay chi hi va minus vb abana question acha pkpm va kp chulana va chu 0 haza minus vb equals to 100 kudile vb chu jang pododing ham so minus 100 volt okay answer pa chana okay then I think this is the last question electric field ki pina to electric field chu piham so 10x I cap so now you're given variable electric field potential at 10 10,20 chi a tiu 10,20 a chu but origin a chi diu na origin chu b tiu ta origin chu 0,0 given chu piham take the potential at 10,2 to be 0 khotile va chu 0 ke pi chu chalai okay again initial minus final va minus vb chu piham integral so 10x na electric field chu I cap bausi amji achu dx I cap chan mukala dina la he okay so here I will have 10 comes out integral x into dx to va minus vb x to limit chu ha pa halai chan ham from 10 to 0 from 10 to 0 okay so gabolos integration so integration of x to x squared by 2 okay limit to 10 to 0 so here I will have 10 into 0 na put version 0 na 0 square by 2 to 0 jing minus 10 square by 2 to 100 by 2 to 50 so that means you'll have minus 500 to va minus vb na va to piham 0 minus vb so therefore vb is how many 500 volt okay formula mandan chu he thim da dingai bolzana variable electric field jong example kala abana chu na constant electric field jong kila so question acho see they can give you either no be thai chu constant electric field jong kipe thai variable jong kipe thai na but abolan ki bang so okay so e into dr he jing na electric field so I cap j cap k cap ahung mala chun chila jong he dx I cap plus dy j cap plus dz k cap sana ji dio Ivan so question as electric field so only I cap ham only along axis ham x axis ham y axis ham bahung ki pi alachun you can write either dx only or dy only okay based on the direction of electric field okay khotile chanju hi sa tauten na hechi relationship between potential to electric field pa hai na previous questions jong JEE jong need jong omde so but I'm not solving anything here so you just go and see those questions you try it yourself okay aji chu chala ya technique pai ka helun ne da na formula pa he formula mandan pai he thim bilang bana you just so go and solve those questions okay khutile he chaning tauten I hope you understand to chukit phal lekhun electrostatics viewte na dipole ho ham ai lo le pm akivar go slow ti hovel khuna hi bol theva jong le bol deu okay then we'll stop here I hope you understand thank you for watching